Okay, let's start. You can see the title and acknowledgements to Guido. Main points of my presentation are here. Boreal areas sequester anthropogenic CO2 and in the same time release carbon dioxide, CO and CH4 with fires. Positive trend in CO fire was found. Fires in permafrost zones was main focus of my analysis. And also the question of alternative fuels. CO total column was measured by AS instrument, sounder, installed at NASA Aqua satellite. Total column amount is easily converted into mean tropospheric concentration, XCO. Example of monthly mean concentration for 2021 August is here. CO was in the range between 80 degrees, which is actually the background concentration, and 160 ppb for the origin or source of fire. Greenish is greenish color illustrates transport of CO from fire zone to the rest of the high northern hemisphere. Our goal is to convert concentration into emission. This is done by box model. All the total northern hemisphere was divided into two boxes, low northern hemisphere and high. The boundary is 30 degrees. These two boxes and CO is emitted from fires and is oxidized by hydroxyl inside this box. Also, another source, another thing for CO is transport between high northern hemisphere and low northern hemisphere through the boundary 30 degrees. As a result of this calculation, we obtained the emission in teragram CO per year for total high northern hemisphere, blue dots. Red dots are obtained by a different technique, absolutely independent technique that is called Global Fire Emission Database by Van der Werf and colleagues. They use the area, the burnt area on the surface of the Earth from pictures taken from a satellite and converted these areas into emission. So what we see that these two independent techniques come to very similar results. Especially it is a quasi-linear trend from 2004 to 2020. After that, the agreement was not so good, especially for Canadian fires of 2023. But our question which area of the hemisphere is responsible for this trend. You see the examples of Siberian fire of 2021 and Canadian fire of 2023. This is August, this is July. And also you see the permafrost zones for both hemispheres also here. And the rest of continent that also have fires, but much less in magnitude, and can be estimated by GFED technique for both these kinds of the surface. Permafrost and out permafrost. And result of this analysis you see for North America and for Siberia. And red lines are for the area outside permafrost zone. And for both for North America and for Siberia, there are no trends in this environment which has boreal forest in southern, more south areas. But for permafrost, absolutely different picture. Discussion. The permafrost zone is partly covered by sparse forest, mainly larch in Siberia and spruce in Canada. The northern part of this area is represented by tundra and rocky desert in the highlands. The recent increase in fires in the subarctic permafrost region needs to be explained. Generally speaking, climate, warming, and dry weather are most likely explanations for that. However, the question arises, does the permafrost zone provide enough biomass as a fuel for the mega fires in 2021 and 2023? What are the alternatives to standard wood and peat? It is conceivable that melting and subsequent drying of permafrost could be number one. And option number two could be fossil carbon, coal, methane, and or oil. Historically, for example, the volcanic formation of the Central Siberian Traps 250 million years ago induced the catastrophic coal fires that resulted in permanent extinction on the entire Earth. In any case, the investigation of emissions from fires should be done, and very important is to harmonize the different methods to come to more reasonable results. Thank you for your attention.